Welcome back, everybody. Welcome back to the channel. So today we're going to talk about lambda expressions, or more specifically, how to process lambda expressions. But in short, a lambda expression is just a quick way for you to basically create a anonymous function and execute it. So let's look at the format for lambda expressions. So let's say we have some variable, um, let's say foo, and that variable is equal to a new lambda expression. Now, ordinarily, you could pass lambda expressions into function calls. You can also assign lambda expressions to other variables, such as maybe it's a variable at this scope, at the class scope, so you're assigning an instant variable or what have you. Doesn't really matter. Sky's the limit. You could also have a new array of function pointers, and you can create a lambda expression in here. You could just create a bunch of various lambda expressions, and then you can call each lambda expression depending on which one you choose in the array, which is really cool because my language supports creating function pointer arrays, so that's really nice. I'm not sure how many languages will actually allow you to do that. That's pretty cool. But anyway, the formatting for lambda is going to be a couple different things. So first, you're going to have what I call the dynamic format, and then you're going to have the explicit format. So really, there's only two main ways of doing it. So with lambda expressions, the format is going to depend on what you're explicitly telling the lambda to return and or have as variables. So there's a little bit, I guess I am going to have to go a little bit into some of the expectation for lambdas. So the expectation for a lambda function is that the compiler has to try to figure out what exactly are you trying to do, but it's going to try to do it in the most limited way possible. So what do I mean by that? Let me just make a function here. So I'm going to say, let's say we want to create a function pointer of foo, and it's going to have a int. Oops, it's going to have an int as its one parameter, and then it's going to have, I don't know, let's say it returns a Boolean, or something like that, right? So if we're going to do that, we're going to need to, in our language, have the name, at least at a minimum, the name of the parameter that we're passing into the lambda, and an optional return type. So we can optionally put this return type here, but basically the point that I'm trying to make is that the compiler is going to try to figure out as much information that it can, and it'll derive any information that's not brought over on either side. So for instance, if I infer the type of foo, I'm going to have to provide the types of everything. I'm going to have to provide the type of num, and say it's an int. I'm going to have to provide the return type. In this case, it's a Boolean. Otherwise, I can just not do anything, and this will basically be effectively returning nil. So this will be basically the compiler will resolve this information as int and nil. So in this case where I infer the type, like I said, I have to explicitly declare what the types are. Now, if I have this case where I declare the types on the left side, well, the compiler doesn't need this information anymore. It's unnecessary. So I can do this, and this is called a dynamic parameter. And what the compiler will do is basically slap this utype onto there. So the important thing to note is that x, y. So for every type you have to put the respective name. Now, I know some lambdas and some programming languages don't require you to do this. You guys got to realize this is the second time I'm writing a compiler from scratch, so I'm not all there yet in terms of everything being really nice and really clean. So I'm still trying to figure out ways of making quote unquote magic happen. So yeah, just this is kind of what we're working with now. So keep that in mind. So, and of course, as usual, I don't think I mentioned it, but if you have no arguments or no names, that effectively means that you're expecting to have a function with no arguments passed in. And same rule applies when you have no arguments. You do not have to pass in or specify the return type. So let's see exactly how they look. So first, we're going to check to see if the next token is equal to a left curly. If so, we want to enter protected mode. because I mean there's still other types of things we have to process with left curly, so this could potentially not be a lambda. So we want to just make sure, just in case if it's not a lambda, then we can cover for that. What we need to do after that is save the old token, as usual. You guys know what that is. We advance one character, and that basically consumes this character because we never advanced. So we consume this left curly. Then we check to see if the next token is equal to the arrow. Let's look at the first case. So we're going to start off with this first one where we just have, this. So this is what we're processing now. So we process this character, we consume this character, and we create a new AST called AST lambda function. We advance one character, and then we parse a lambda return type. So if we go into here, lambda return type is an optional return type, and you basically check to see if the next token is a left paren. If so, we create a branch called AST method return type. This is very important. We're going to be reusing this same type of syntax in multiple areas in our language. So it needs to be AST methods return type, and it also needs to have like the same format. So we expect the left paren. We don't need to add the token, so we say false. And then we check to see if the next token is equal to nil. Nil in my programming language was something that I added a lot later on. So nil is kind of detached from parsing a U-type. Nil isn't really a U-type, which I guess kind of makes sense because nil is nothing and nothing isn't a type. So I guess, but yeah, that's why it's kind of detached from parse U-type. But yeah, so we need to check to see if the next token is equal to nil. If so, add that or advance to this token and then add the token. Otherwise, we just parse a U-type and then we close out by parsing our ending paren or our right paren. And of course, we don't need to add that as well. So if we go back up to where we were, we fail the errors because at this point we know like we're processing a lambda expression because we have this little pointy thing here. So we fail the errors and we parse a lambda block. So literally all a lambda block is the same thing like every other block we've processed. The only differences with this versus every other block is if you guys remember, like blocks typically have a starting and a ending curly brace, and some blocks even have optional start and end curly braces. Like for instance, I could say if true, right? And then I could say if true, return 100, right? So, or more specifically, if size is equal to 123 or something, I don't know, like if some expression evaluates to true, return this value. In here, this is technically a block, just it doesn't have the curly braces. So the difference with this one is that we've already processed the curly brace, so we don't need to process the beginning part. We just process the ending part. But literally everything in here is exactly the same as everything else we've already seen throughout the series. We loop while we are not at the end of the file. We have our error check limit here. We advance a character. We have the same silly logic for right curly and left curly. Now, the only difference is that we're not keeping track of how many like branches or curly braces we have because like this parse block function will do that for us. So when we do that, it'll have like the necessary logic in there to keep track of all the curly braces and everything. So we just advance. If it's a right curly, we decrement the current token and we break out of this loop. And then of course we just process the right curly. Otherwise, if it's a left curly, we decrement the current token and parse a block. We've already created this function, so I don't have to go over it. Otherwise, if it's the end of the file, then we just say unexpected end of file, obviously, because we're not done parsing this lambda block. We break. Otherwise, we just parse a statement. Now, I've recently been making headway on the programming language, and I need a lot of time. So I hope you guys bear with me. I know that you guys are ready to get to the fun stuff in regards to actually compiling all of this code, but I still need some time. So please be patient with me. I'm working really hard to get this compiler finished, but I did start working on statements, as you can see here. Not everything is commented out. There's quite a lot more stuff uncommented, so it looks like we are going to stay in the parser file for quite a bit longer. So I know I'm stalling, but I need the time. So hope you guys can understand. But anyway, we basically check to see if we did not parse a statement correctly, we break because I don't know, maybe there's something wrong. And we clear out our access types at the end every time we loop. This is not really, we don't need that. Okay, so never mind that, just ignore that. Um, but yeah, also, I don't remember if we went over the parse statement function. Just create this right now. We're not going to go into statements yet, but all you need to know is that it returns a Boolean, and yeah, so just create this function, maybe add like the first things like getting the branch of AST statement and checking the error limit, and then processing your access types. This is the same code that's in every other function that processes access types, and then just return like false or something. We'll get into parsing statements later. So let's go back to the top. So that is parsing lambda blocks. Whoops. So once you parse your lambda block successfully, we want to reset the branch to the new AST, which is, this is the lambda function AST. So we want to reset the branch to that, and we basically add this code here. Now, in this case, we're not, like, we can't cast a lambda block to anything, so it doesn't really make any sense. In fact, I'm going to do this live. I'm going to do a check. So if there is an as, then I'm going to lambda block, here it is. We want to actually error out. So we want to say unexpected symbol as, because you can't cast a lambda function to another type because it doesn't make any sense. So just make sure that you complain about this because that, like I said, that doesn't make any sense. But yeah, so also I'm going to remove the support for this. I don't know why you'd want to increment or decrement a lambda function. So I'm going to actually, here, I'll just do this. Copy this code here. And yeah, so we're not going to support anything. We're not supporting increment or decrement, so just make sure you say unexpected symbol and make it dynamic by getting the next token's value. Say unexpected symbol, whatever the value is. We don't allow dots, we don't allow left brace or as. And I'm just going to copy all this code here and paste the same crap there. All right, so that is the format for just a single lambda function with no arguments. Now let's look at the lambda function with arguments. So this is how we basically determine if we're processing an actual lambda function with x, y, z. So first we create a new AST. So if it's not immediately the pointer token, if it's like a in this or x in this case, then we are going to create a new AST of AST lambda function once more, and we parse a lambda arg list. So in there, a lambda arg list is basically, we first create a AST lambda arg list branch, and then we process a lambda arg. And again, as you guys notice, I try to keep things consistent. This is the same format like everything else. So with this, it requires you to at least process one lambda argument. So if we ever call this function, like I know some functions have like optional things that we can process, but if we call this one, we have to have at least one lambda arg. So yeah, so let's see what a lambda arg is. All right, so we create a branch of AST lambda arg, and we do checks for a variable declaration. So if you guys remember, right, we have two formats. So we can either like say like just the names of the argument, or we can basically provide the type of the argument. So, and the reason why you want to do this is, let's say you have on the compiler side a lambda or a function that requires a lambda function to execute some code, and maybe you have two functions that have three parameters. Well, the compiler's not going to know which one you need to basically process. So here, I'll actually give an example. So let's create a foo, and let's create another foo. And if we, so we have like this foo function, and I'm gonna remove this here. Let's say we expect, let's say we have like a sort function or something, sort, and the naming and everything doesn't really matter. I'm just trying to prove a point. So let's say this one requires a string, int, and int. And then let's say this one requires a string, int. So in this case, if we try to call foo, how's the compiler going to know which lambda function or which function to call if we just do this? That, I mean, it's impossible to know, because like we don't even know what this returns. So like, I mean, in this case, these don't really have return types, but we don't even know what this returns. So it's impossible for the compiler to know. So the way we would differentiate it is just say like int. If we put int in the middle argument, this is like the minimum amount of data that the compiler needs to figure out which function to call. It's going to call this function because it knows that even though we don't have the data for this one and this one, it matches this function because this has an int here and this one doesn't. So yeah, that's why we have that format. So if we look here, we can see we have our is variable check, which basically all it does is check to see if the current token is an identifier and it's not a keyword. So if our current token, or if the next token is an identifier and it's not a keyword, and the token after that is equal to the colon, then we basically expect an identifier, expect the colon. We don't need to add it, by the way. And then we parse the utype and we return true. Otherwise, if we expect the identifier, we return true. Otherwise, we return false. Why this returns a Boolean, I have no idea, but yeah, that's how that looks. So that allows us to have either format here, as you can see. So if I go back up to parse lambda arg, you can see here, if we successfully parse one lambda arg, then we check to see if the next token is equal to a comma. If so, we expect the comma. We do not need to add the comma either. Here, I'm just going to do that. And we parse the lambda arg, go back up to the top, rinse and repeat. Same thing as we always do. So after that, we check to see if the next token is equal to a pointer. So in this case, if this wasn't equal to a pointer, then what this would effectively, what the compiler would effectively do is backtrack all of this code and assume that this is some other type of expression. Now, obviously, if we did this, it would break, but if we did like X, Y, and Z, the compiler is going to think that this is maybe like a dynamic array that we're trying to create because we don't have the arrow symbol here. So we assume or we check to see if the next token is equal to the arrow symbol. Then if so, we advance. Otherwise, before we get into all this, if it's not equal to the arrow symbol, we free up the last sub AST because if you remember, we only created one AST here. So we created the parse lambda arg list. So we need to free up that AST. We pass the errors, so we ignore any errors that may have been generated as a result. And we reset the current token to its old value. Now, if it turns out to be a lambda function because we found the error symbol, or the arrow symbol, I don't know why I keep saying error, we advance one token, we parse a lambda return type, we print out any errors if there were any, we parse a lambda block, and then we have some code down here which basically just checks to see what the next token is and error out if there's like something after it. Same code that was up here that we just went through, so I don't really have to go over it. But yeah, so that's pretty much it. That's how you parse lambda functions. I'm gonna do this. I'm gonna say foo is equal to that because we need to do variable declarations. And I'm gonna go back here to parser, parse variable declaration, and do that. All right, let's see what happens. So if we look here, so we have our foo function or foo variable. So now we need to assign it this lambda expression. So here, actually, that's probably a bad idea. I'm going to start out very simple and just do the blank lambda expression. So if we look at that one, it's pretty simple. So we have our primary expression, we have a lambda function, and we have just an empty block, which would contain all of our statements in here. Now, if we say x, let's put one variable name. Let's see how that looks. So we have our lambda function. Where is the, okay. So we have our lambda function, our lambda arg list. We have one argument. It's called x, and this is a lambda arg. And then we have, of course, our empty block again. X, y, type int, comma, z. You can see how that one looks. So if we go back, we have our primary expression, lambda function, parse lambda arg list. We have 3 this time, so that's good. Looks like we have 3. We have a AST lambda arg, we have an X, we have another AST lambda arg. This one's a little bit more complicated because it has the type. So we have the name of the argument, Y, and then we have the U type of identifier, reference pointer of an int. So that's looking good. Finally, we have our last lambda arg of Z, and we parse a block. Finally, let's see how this one looks. So I'm going to show you with nil, and then I'm going to show you with a utype. So go back up to the top. I mean, we've already seen that, so I don't really have to go over that. Okay, so we have our AST method return type here, and we can just see we have the simple token of nil. So now, if I actually put a utype, which is like here, let's put object. Say it returns an object. Then we can go back and see it actually returning a utype. So if we look at our AST method return type, we have a utype type identifier of object. So that's going to be it for today, guys. As usual, if you guys have any questions, definitely write them in the comment section below. Also, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you get there, watch, star, and fork the repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you guys are interested in learning maybe the stuff that I do on a daily basis with the language in terms of updates, bug fixes, you can check out the remastered branch. Pretty much anything other than master and remastered aren't used, so keep that in mind. And when you guys get there, you can check out my commits. I write some pretty wordy commits, so you can kind of get the gist of what I'm doing in the commits without really having to go deep into the code. But if you guys are interested in maybe seeing some of the things that I've done to the code base in terms of updates or bug fixes in a more detailed description, you can go to the doc folder. And in there's going to be two main files. You can check out the changeless file. That's going to be pretty much everything that I've done to the language in the past. And then you can also check out the roadmap file, which contains pretty much everything that I've already done to the language, as well as stuff that I'm looking to add into the future. I would highly recommend you check this file out. It's really interesting. It definitely gives you an insight into the programming language, as well as like stuff that I'm looking to add, like I said, in the future. But yeah, so that's going to be it for today, guys. If you guys are new to the channel, definitely consider subscribing. And as always, until next time, I'll see you guys later.